Hello, and welcome to Physics Online, a series of tutorials designed to help you learn physics. But before we get into today's topic, let's talk about some of the advantages of online physics videos. One of them is by placing some of the basic content of this course in a video, we will have more time in class to apply the concepts in laboratory exercises and problem assignments. You'll be able to work with your classmates on the problem assignments, and I will be available to help. The second advantage is that if you are absent from class, the lecture material is available online for you to access so you can keep pace with the class. The third advantage is that if you forget a physics concept or you need a review for a test or a midterm exam, the video material is always going to be available. A fourth advantage is that you will start to become an independent learner. Now, what do we mean by an independent learner? Well, what we want you to do is to be able to take some of these concepts, all right, and learn them well enough so that when you come to class, you can apply your knowledge of these concepts and show that you understand what it is that you've learned. And how do you become an independent learner? Well, you start by finding a quiet place to work, or you may need to use earphones to minimize the distractions. In other words, you want to make sure that you can hear the videos clearly and that you're able to think about them without any distractions. A second aspect of becoming an independent learner is that these physics videos are interactive, and so you will need a pencil, your student supplement, and in some cases a calculator. Those who are not actual students of mine, you won't need a student supplement, but I highly recommend that you get some paper so that you can write down the answers, do the calculations as a means of checking your understanding of the material that is presented. Throughout the video presentation, I will ask you to use that pause button, very important, to push the pause button. This will allow you time to think about the concepts and to test your understanding of the material by answering the questions presented in the video. If you have any questions about the material, write them down in the student supplement and we will discuss them in the class the next day. Okay, let's start with today's topic. Today's topic is vectors and scalars. Vectors and scalars, we'll be talking about vectors and scalars throughout the rest of the year. They're one of the most important concepts in physics. First of all, what is a scalar? A scalar quantity is one that has magnitude only. That is, it has a numerical value associated with it. It could also have units attached to it, then that's fine. Here's an example. We have a car of mass 1,000 kilograms that travels a distance of 25 meters at a speed of 15 meters per second on a day when the temperature is 14 degrees. In this sentence, the scalar quantities are mass. Certainly a mass is because, as you can see, it has a magnitude of 1,000 kilograms. Temperature is certainly a scalar quantity. It has a magnitude that is a numerical value, in this case equal to 14 degrees. Now what I would like you to do is to push that pause button and fill in these two blanks right here. Read through this sentence and see if you can identify two more scalars in this sentence and write them down right in here. Okay, so push that pause button. Okay, let's see what we got for answers. The answer I came up with was distance. The distance of 25 meters, that's certainly a scalar quantity. And the speed of this vehicle was 15 meters per second. That's the magnitude for this particular quantity. So from now on, when we use these terms in the physics class, or a textbook uses them, distance and speed are always going to be considered scalar quantities. That is, they have a magnitude only. Much of physics is actually learning the vocabulary. In other words, we won't be able to communicate in physics unless we understand the vocabulary clearly. Now, we've understood what a scalar is. What then is a vector? Well, this example right here will help us understand what a vector is. In this case, we have a car that travels at 25 meters per second due north. Now, at first glance, it looks like it's a scalar. It has a magnitude, right? But this is something more than a scalar. It has this direction right here. So now you should be able to tell me the definition for a vector quantity. It's a quantity that has both what and what. So push that pause button, and in your student supplement, fill in the blanks, or if you just have a piece of paper, write down the answer to this particular question. Okay, let's see what we have for answers. A vector is a quantity that has both magnitude and direction. So this up here is called a velocity vector. And you might note that there's a little arrow right over the top of this variable that represents velocity. Some textbooks use that to indicate that this is a vector quantity. And so from now on, when we talk about velocity, when we use that term velocity, we are talking about a vector quantity. That is, we will have to specify both the magnitude and direction. Okay, let's continue. Suppose we have a particle moving along the x-axis or the y-axis, okay, and it can have its direction determined by a positive or negative sign. For example, if I have a particle moving along the x-axis like this, then I can say that, well, it's going in the positive direction, right? If I have the particle, however, moving in the opposite direction along the negative x-axis, then we would say it's going in the negative direction. And the same is true for something moving vertically. Up we could say was positive, and down we could identify as being negative. However, for a particle moving in 2 or 3 dimensions, that is, suppose we have something moving at an angle like this, okay, well, what is that? Is that going to be positive or negative? Well, it's not easy to identify the direction by using positive or negative, and so we're going to represent this vector by an arrow, and we're going to represent it in terms of an angle. So let's see how that works. Let's talk about this velocity vector, the one that was 25 meters per second. And let's say that this velocity vector can be represented by an arrow whose magnitude is represented by its length. And the direction of this vector is represented by the arrowhead direction. For example, suppose my velocity vector is pointing due north, right? So here's the magnitude, right? And that corresponds to the particular length, and the arrowhead indicates the direction for my velocity vector. Now what I would like you to do, right in this space here, I want you to draw another velocity vector. This time, this one is only 12.5 meters per second. In other words, it has half the magnitude of this one right here, and also it's going due south. So in this space right in here, draw in that particular velocity vector. And then go over here and draw the velocity vector v equals 25 meters per second due southwest. And I provided you with a reference system. We have an XY axis here, and east is this way, north is this way, west this way, and we're going to have our starting point right here at the origin. And so I want you to draw a vector that's going due southwest. See if you can do that. Push that pause button and give it a try. Okay, let's check our answers. First of all, you should have drawn a vector that basically is half as long as this one right here, because it has half the magnitude. And you should have drawn it going due south, because that's the direction for this particular velocity vector. Over here, we wanted to draw a velocity vector going due southwest. Starting at the origin, you would go in this particular direction, and the angle that it makes with respect to the vertical here is 45 degrees, and likewise the angle that it makes right here with respect to the horizontal is also 45 degrees. That's what we mean by this vector going due southwest. Okay, let's take a look at this example right here. Often we will use a coordinate axis as a reference system for our vectors. Draw the displacement vector delta x equals 30 meters, 60 degrees north of east on the following axis. That's this axis right here. And this is a displacement vector. From now on, when we use the word displacement, like when we use the word velocity, they're going to imply that we're talking about a vector quantity. Let's go back over here a little bit here. Note delta x is read delta x. This is the Greek letter delta, and what it really means is that it's the change in the position of x. Or we could write it as delta x equals x final, the final position, minus xi, the initial position. So what we're talking about is over here, we're going to draw a vector. It's basically starting here, and we're going to draw it so that it goes at an angle of 60 degrees. So this vector basically, what it means by going north of east. Look, if we were to go directly along the easterly direction, we'd go this way, right? But we want to get on my vector, so I've got to go toward the north, that is toward the north, at an angle of 60 degrees, that is right toward the north, to get on my particular vector. Okay, so that's what we mean by 30 meters. That's the magnitude that would correspond to the length. That's the displacement. From here to here is a displacement of 30 meters. And then the direction is 60 degrees north of east. Now I want you to note that this displacement vector could have been identified, the direction could have been identified in another way. I'm going to give you a hint. We're talking about basically this angle right here. How could I represented this vector by this particular angle? I want you to push the pause button, think about it somewhat, and see if you can give an expression for another way of identifying the direction for this particular displacement vector. Let's check our answer. The answer I came up with was 30 degrees east of north. In other words, if we go over here and go due north, right, we'd be going right along this arrow. But I want to get on my vector, so I'm going to have to go 30 degrees. Okay, that's the complement of 60 degrees. 30 plus 60 is 90. So I'm going to have to go 30 degrees in this direction, that is toward the east. So that's what we mean by east of north. If I went due north, I'd go this way, but I got to go toward the east to get on my vector by a 30-degree angle. So in other words, the direction of this particular vector could be described as 60 degrees north of east or 30 degrees east of north. Either one is perfectly appropriate. Notice that the 60 degrees is the complement of 30 degrees, and notice that these north and east were interchanged to get east and north. Okay, let's test our understanding of vectors and scalars. What I'd like you to do is push that pause button and read through these true or false and come up with an answer. Okay, here's the answers to our true and false. And if you have any questions about this or any part of the video, then please write them down and we'll discuss them tomorrow at the beginning of class. As for now, I thank you for watching and I hope you learn some physics.